Hello and welcome. In this video, we are discussing about factory method design pattern. So the factory method design pattern is a creational design pattern that provides an interface for creating objects in a superclass, allowing subclasses to alter the type of objects that will be created. And this pattern is particularly useful when the exact types of objects to be created may vary or need to be determined at runtime, enabling flexibility and extensibility in object creation. So what is factory method design pattern? So the factory method design pattern is a creational design pattern used in software development. It provides an interface for creating objects in a superclass while allowing subclasses to specify the types of objects they create. This pattern simplifies the object creation process by placing it in a dedicated method, promoting loose coupling between the object creator and the objects themselves. And this approach enhances flexibility, extensibility, and maintainability, enabling subclasses to implement their own factory methods for creating specific object types. So when to use the factory method design pattern? So if your object creation process is complex or varies under different conditions, using a factory method can make your client code simpler and promote reusability. The factory method pattern allows you to create objects through an interface or abstract class, hiding the details of concrete implementations. This reduces dependencies and makes it easier to modify or expand the system without affecting existing code. If your application needs to create different versions of a product or may introduce new types in the future, the factory method pattern provides a flexible way to handle these variations by defining the specific factory methods for each product type. Factories can also encapsulate configuration logic, allowing clients to customize the object creation process by providing parameters or options to the factory method. Components of factory method design pattern. So the main components of factory design pattern are: first, creator. This is an abstract class or interface that declares the factory method. And the creator typically contains a method that serves as a factory for creating objects. It may also contain other methods that work with the created objects. Concrete creator. Concrete creator classes are subclasses of the creator that implement the factory method to create specific types of objects. And each concrete creator is responsible for creating a particular product. Product. This is the interface or abstract class for the objects that the factory method creates. And the product defines the common interface for all objects that the factory method can create. Concrete product. Concrete product classes are the actual objects that the factory method creates. And each concrete product implements the product interface or extends a product abstract class. So factory method design pattern example. So the problem statement to understand factory method design pattern. Consider a software application that needs to handle the creation of various types of vehicles, such as two-wheelers, three-wheelers, and four-wheelers. Each type of vehicle has its own specific properties or behaviors. So without a factory method design pattern, import java.io abstract class vehicle, public abstract void print vehicle, class two-wheeler extends vehicle, public void print vehicle, system.out.println I am two-wheeler, class four-wheeler extends vehicle, public void print vehicle, then for I am four-wheeler, then class client pub private vehicle, public client int type, that's the code, then public class gfg, public static void main string args, client p client equal to new client, like that. Then issues with this design. So the client class creates two-wheeler and four-wheeler objects directly based on the input. And this strong dependency makes the code hard to maintain or update. The client class not only decides which vehicle to create but also handles its life cycle. And this mixes responsibilities which goes against the principle that a class should only have one reason to change. To add a new vehicle type, you must modify the client class, which makes it difficult to scale the design. This conflicts with the idea that classes should be open for extension, but closed for modification. Solution to the problem. So define a factory interface. Create an interface vehicle factory with a method to produce vehicles. Create specific factories. Implement classes like two-wheeler factory and four-wheeler factory that follow vehicle factory interface, providing methods for each vehicle type. Revise the client class. Change the client class to use a vehicle factory instance instead of creating vehicles directly. This way it can request vehicles without using conditional logic. Enhance flexibility. This structure allows for easy addition of new vehicle types by simply creating new factory classes without needing to alter existing client code. With factory method design pattern, let us break down the code into component-wise code. Product interface vehicle, four-wheeler, two-wheeler, then vehicle, two-wheeler factory method. So product interface, Java, public class, abstract class vehicle, public abstract void, print vehicle. Concrete products. Concrete product classes representing different types of vehicles. Public class two-wheeler extends vehicle, public class four-wheeler extends vehicle. Then create interface, factory interface. Factory interface defining the factory method, public interface vehicle factory, vehicle create vehicle. Then concrete creators, concrete factories, concrete factory class for two-wheeler, public class two-wheeler factory implements vehicle factory. Then public vehicle create vehicle return new two-wheeler. Public class four-wheeler factory implements vehicle factory. Concrete factory class for four-wheeler. Public vehicle create vehicle return new four-wheeler. So complete the code of this example. Public abstract class vehicle, public abstract void print vehicle, class two-wheeler extend vehicle, public void print vehicle, system.out.println I am two-wheeler, class four-wheeler extends vehicle, public void print vehicle, system.out.println I am four-wheeler. Then the factory interface, vehicle factory, vehicle create vehicle. Class two-wheeler factory implements vehicle factory. Public vehicle create vehicle. Return new two-wheeler. Then class four-wheeler factory implements vehicle factory. Public vehicle create vehicle. Return new four-wheeler. Then class client this output. So in the above code, the vehicle serves as the product interface defining the common method print vehicle that all concrete products must implement. Two-wheeler and four-wheeler are concrete product classes representing a different types of vehicle implementing the print vehicle method. Vehicle factory acts as a creator interface, factory interface with a method. Create vehicle representing the factory method. Two-wheeler factory and four-wheeler factory are concrete creator classes implementing vehicle factory interface to create instances of specific types of vehicles. Use case of factory method. The main use case for factory method design pattern used in JDBC for creating connections and in frameworks like Spring or managing beans. So advantage of factory method, main advantage of factory method, separation creation logic from client code and improving flexibility, and new product types can be added easily. Hides specific product classes from clients, reducing dependency. So this was a brief discussion on factory method design pattern. Thanks for watching this video. Bye for now.